Hello, I am Joel Surfleet. I simulated liquid sloshing in a container using ANSYS Fluent. The first simulation is of coffee and milk sloshing in a mug that is being oscillated left to right 5 cm from the origin at 1 Hz. The second simulation is the same system, only focusing on the coffee. The others are all simulations of liquid hydrazine and gaseous nitrogen in a 10 cm cubic tank. Here are the equations I used to model the shaking of the container and how I derived them. I found that the time step used for the calculation had a large effect on the result. I used a time step of 0.001 for most sims. I simulated the same 10 Hz, 60 Hz and 120 Hz for the cases of the tank being 40, 50 and 60% full. I used a time step of 0.05 for the 10 Hz simulations when 50 and 60% full sim, since this is 2 times the period of the sloshing expression used. That is why the behavior is so symmetric. At 120 Hz was noticeably greater than the others, and as time goes on it seems to thoroughly mix. If you wanted to use this fuel tank to feed an engine, you could have trouble with combustion instability, especially if it was to be used in a bipropellant rocket engine. Depending on the injector, you could think about treating the mixture as a 2-phase mixture that is very well mixed and use these simulations to calculate the quality. A monopropellant engine might be able to handle gas bubble in the fuel due to sloshing better than biprop, and hydrazine is usually used as a monoprop. The actual simulation done here is at sea level, with gravity still pulling down, so really this is like a case of a CubeSat at launch. Now that we have simulated the sloshing for the vibrational modes it will experience, we should look at the forces they will impart on the walls to see if the CubeSat will survive launch. We could reduce the sloshing to reduce those forces by adding baffles or making the fuel tank smaller so there is less empty space. The tank shouldn't be partially full at launch. Thanks for watching.